one-way ANOVA in SPSS followed by post-hoc tests. One-way ANOVA is one of the statistical tests that is performed to compare between groups and look at differences between means. It is used when the number of groups is equal to 2 or more, but it's more commonly used for 3 groups and more. So the ANOVA will look at the differences between the groups and determine whether there is a significant differences between the groups. Here in this SPSS data viewer had inserted 100 cases for individuals. One of the variable here is labeled as job, showing 4 different categories of professions: doctors, dentist, pharmacist, and nurse. And each one of them has been coded for 0 for a doctor, and 1 for dentist, and 2 for pharmacy, and 3 for nurse. For a second variable is the salary, which shows how much those individuals earn annually for doctors, for pharmacist and dentist and nurse. Again, there is variation on those salary range between doctors, dentists, and pharmacists and nurses. And here I have 25 participant or 25 cases of doctors and similar dentists, pharmacists, and nurses. And in a third variable I had inserted saving, how many saving those individuals managed to keep at their bank after working for at least 10 years, and the salary is, as I said, measured annually. So to compare between those individuals, the 4 groups, and to find whether there is a significant differences between the salaries, we're going to use ANOVA to do that. ANOVA in SPSS can be performed in 2 different ways. The first one is through clicking on Analyze, then scrolling down to Compare Means, and then to One-Way ANOVA. Click on that, and then a window will appear. I'm going to reset that. In this window, I'm going to move the factor, which is the group job, into the factor space, and then I'm going to move the salary to the dependent list. And I'm going to select options, click on descriptive, homogeneity of variance, and I will include Brown, Forsyth test, and Welch test, and also will plot the means. Click on continue, and for post-hoc, since we presume that there is equal variances, I'm going to stick to 2 key. Tick that box and then click on continue. If you click on OK, output is generated. In the first table, descriptive shows the salary for all the 4 professions, and there are 25 individuals in each profession, and the mean for each occupation is inserted here. And as we can see, there is a difference between the salaries for those individuals. However, in the standard deviation, we can notice that the standard deviation for each group is very close. So that's also given insight that there is homogeneity of variance. And one of the assumptions for ANOVA that has to be met, it should be a homogeneity of variance, and that is given in the next table. it shows that there is a homogeneity of variances between those 4 groups of individuals. The third table is the ANOVA table, which shows that there is a difference between the 4 groups, as it is measured by a test called F test, and a significant value of less than 0.05. So the ANOVA table here shows that there is a significant differences between the 4 groups, but it doesn't, the ANOVA does not specify which bears what combination of professions that they have the differences. For the next table, which is robust test of equality of mean using Welch and Brown Forsyth test, again this is irrelevant here, as there was a homogeneity of variances and the assumption has been met for ANOVA, so we're going to exclude this from the analysis for this set of data. And then another table is generated for the comparison, which is the multiple comparison between each group to find possible combination, all the possible combination comparison between groups to find out which combination has a statistical significance in the salary for the participant. Again, as we can see, comparing doctor with dentist, there is a significant differences in the salary between doctor and dentist, doctor and pharmacist, doctor and nurse, as the p-value was less than 0.05. So these data shows that there is a significant, based on the ANOVA table here, there is a significant difference between the groups. And then the test we chose here, Toki test, determine which pairs or which 2 groups shows differences. Again, here we can see all the groups have differences in the salary range. The final graph shows the mean for the salary for all the 4 occupations is decreasing. The doctor has the highest salary and the nurse the lowest salary. So this test shows that there is a differences between the 4 different groups. So this is one of the way to do ANOVA. Another way is to click on Analyze and then scroll down to General Linear Model and then click on Univariate, reset that, and I'm going to move the job to the fixed factor and the salary to the dependent variable. And in the plot, I'm going not to select anything at this stage. In the post-hoc, again, I am going to move this job into the post-hoc test for the jobs, and I'm going to take the 2 key when there is an equal variance assumed, as we can assume now. I've double checked that there is an equal variance. Click on Continue for EM, and I'm going to move this into the click on it and move it into display, and I'm going to compare the mean differences as selected here. Click on Continue. In the Save options, I'm going to take and standardize predict variable values. Click on Continue. In the options, I'm going to take in descriptive statistic homogeneity of test, which is Leven's test, and also estimate of the effect size. Click on Continue, and then if I click on OK, the univariate analysis output is somehow similar to what we have done in the previous one, Way ANOVA. It shows here the first table between subject that we have doctors, there are 25, and similar to dentists, pharmacists, and nurses. The second table is descriptive statistics, shows that the mean for each individual salary for each profession is different. However, standard deviation is nearly similar for all the 4 professions. These data are not different from the previous analysis we've just done. And for the test of variances, homogeneity of variances, here we can see this table shows that the variance is homogeneous between all the 4 groups, and the value here as given by the significant value, which is greater than 0.05. Again, for the this test generate between subject effects, and it has a F ratio and significant, and we are here interested on the job. Shows that there is a significant differences between occupation in terms of the salary. A partial test shows the effect size, which is high here. Again, another table is generated, Toki test, showing the difference between the means and the significant value. All the possible combination between pairs of professions and the significant. There is a significant difference between all 4 occupations. And finally, as shown here by Toki HSD, and that's basically how the ANOVA test is performed in SPSS. Now I have also inserted here another variable, which is the saving, and I'm going to do an analysis on this saving variables to look at whether there is a significant difference between occupations, the 4 different occupations, and saving. So again, I'm going to use analyze, click on analyze, compare means, then select Way ANOVA, and I'm going to remove the salary and insert saving, and then keep all the setting the same. Click on OK. Again, a descriptive table is generated showing all the 4 occupations with the sample size for each variable, and the mean. As we can see here, there is a variation in the mean, and so there is a difference between the groups. However, the standard deviation does vary here, varies, as we can see, so thus indicate a heterogeneity on variance. Again, testing for homogeneity of variances indicate that these 4 groups are heterogeneous. So this is in terms of variances, so this assumption has been violated for ANOVA. Thus, this table ANOVA cannot be used for interpretation, and the F factor here, we have to go and instead use the Welch and Brown's Forsyth test for comparing between the groups, as it's robust. It shows here that there is a significant differences between the groups, which is both of them nearly less than 0.05. Since there is a violation of homogeneity of variance, then this table need to be reported instead of the ANOVA. And to look at the comparison between all possible combination of groups, then we are here going to select, since there is no homogeneity, we have to visit this again. We need to select the post-hoc here, since we know that there is unequal variances, then we will untick this and then tick the Games-Howell for unequal variances and click on continue. And as we can see here, the Games-Howell is generated and shows that there is a significant difference between all possible combinations of professions. And graph here plotting the mean shows that the saving is the highest for doctors and it's lowest for the nurse. So this is the way to do ANOVA in SPSS when you have homogeneity of variances met, or when the homogeneity of variances is violated.